Hello everyone. Today we will be doing the deflection of trusses joints. So we will be using the method unit load method and explaining how to calculate the deflection in that. So when you are talking about the trusses, the method is said to be the Maxwell method or unit load method. So what is the case one here says that due to what is the external loading. So when you are solving the trusses numerical to calculate the deflection at any joint, either he may ask you to calculate the vertical deflection or horizontal deflection. So आप डिफ्लेक्शन कैलकुलेशन कैसे करेंगे? देखिए, जिस डायरेक्शन में आपको डिफ्लेक्शन कैलकुलेट करने के लिए बोला है उस डायरेक्शन में आपको एक यूनिट लोड अप्लाई करना है. तो सब फर्स्ट ऑफ ऑल आपके स्टेप क्या है? फर्स्ट ऑफ ऑल स्टेप जो अभी तक आपने बीम्स में किया था वो सेम प्रोसीजर है. पहले आप अननोन रिएक्शंस कैलकुलेट करेंगे ड्यू टू दी एक्सटर्नल लोडिंग, जो एक्सटर्नल लोडिंग ट्रसेस पे गिवन है उसके अकॉर्डिंग जब अननोन रिएक्शंस आपके आ जाएंगे तो आपको जिस जॉइंट पर डिफ्लेक्शन निकालने के लिए कहा गया है, आइदर वर्टिकल डिफ्लेक्शन और हॉरिजॉन्टल डिफ्लेक्शन, उस डायरेक्शन में आपको एक यूनिट लोड लगाना है और उसके कारण आपकी मेंबर फोर्सेस क्या है वो कैलकुलेट करनी है. सो आगे के प्रोसीजर में आपको बताता हूँ. पहला केस देखिए, ड्यू टू एक्सटर्नल लोडिंग टू फाइंड द डिफ्लेक्शन ऑफ जॉइंट सी फॉलोइंग स्टेप्स में बी यूज्ड. देखिए अब इसने कहा है सी जॉइंट जो है इसमें इसमें डिफ्लेक्शन फाइंड करना है, वर्टिकल डिफ्लेक्शन. तो कैसे फाइंड करेंगे? देखिए पहला स्टेप है ड्यू टू गिवन लोड सिस्टम कैलकुलेट द फोर्सेज इन ऑल द मेंबर्स. तो ये जितने भी मेंबर्स हैं 1 2 3 4 5 6 7 8 9 10 11 12 13. सो ये 13 मेंबर्स हैं. इसमें आपको क्या निकालना है? मेंबर फोर्स. सो हर मेंबर फोर्सेस को यहाँ पे नेम किया गया P1 P2 P3 एंड सो ऑन टू PM. ठीक है, तो इसको बोलेंगे P सिस्टम ऑफ फोर्सेस. सो ये कौन सा सिस्टम ऑफ फोर्सेस है जो आप निकालेंगे? ड्यू टू दी एक्सटर्नल लोडिंग. So the forces P system of forces can be calculated by using the method of joint. उसके बाद आपको जो मेंबर फोर्सेस निकालनी है वो आप इजीली मेथड ऑफ जॉइंट्स मेथड से निकाल सकते हैं. नेक्स्ट स्टेप आपका जो इस मेथड में है, रिमूव ऑल द गिवन एक्सटर्नल लोडिंग एंड अप्लाई यूनिट लोड एट सी इन द डायरेक्शन ऑफ द डिजायर्ड डिफ्लेक्शन. सो आपको क्या करना है? जो एक्सटर्नल लोडिंग ट्रसेस पे गिवन है उसको रिमूव कर देना है. आपको एक फ्रेश ट्रस बनाना है जिसमें आपको जिस जॉइंट पे कैलकुलेट करने के लिए बोला है डिफ्लेक्शन, उस डायरेक्शन में आपको एक यूनिट लोड अप्लाई करना है. सो फिर उसके बाद आप उस यूनिट लोड के कारण मेंबर फोर्सेस कितनी आती हैं वो आपको कैलकुलेट करना है. सो ड्यू टू यूनिट लोड अलोन फाइंड द फोर्सेज इन द मेंबर सेज K1 K2 एंड सो ऑन टू Kn. इस सिस्टम ऑफ फोर्सेस को बोलेंगे के सिस्टम ऑफ फोर्सेस. अब के सिस्टम ऑफ फोर्सेस वो फोर्सेस हो गई जो आपकी यूनिट लोड की वजह से आपके मेंबर्स पे आई. ओके, सो आई होप इतना क्लियर हो गया हो आपको. नेक्स्ट स्टेप आपको क्या करना है? डिफ्लेक्शन कैलकुलेट करना है एट जॉइंट सी. सो द डिफ्लेक्शन ऑफ जॉइंट सी इन द डायरेक्शन ऑफ द अप्लाई यूनिट लोड इज गिवन बाय, उसके लिए एक फॉर्मूला है दैट इज डेल्टा सी समेशन ऑफ पी के एल अपॉन ए. पी क्या है? जो आपने मेंबर फोर्स निकाली थी इन ऑल द मेंबर्स, मेंबर ऑफ फोर्सेस पी निकाली थी आपने ड्यू टू एक्सटर्नल लोडिंग. फिर के क्या है? के क्या है? मेंबर फोर्सेस ड्यू टू पॉइंट लोड. फिर एल क्या है? लेंथ ऑफ द मेंबर. ए क्या है? एरिया ऑफ दैट सेक्शन मेंबर. ई क्या है? इंच मॉडुलस ऑफ इलास्टिसिटी. सो इफ ये डिफ्लेक्शन अगर आपका यहाँ पे ये डी मेंशन है, बट डिफ्लेक्शन, इफ डिफ्लेक्शन कम्स आउट टू बी पॉजिटिव, द डिफ्लेक्शन ऑफ जॉइंट सी विल बी इन द डायरेक्शन ऑफ द यूनिट लोड. अगर ये डेल्टा सी की वैल्यू पॉजिटिव आती है तो इसका मतलब होगा कि जिस डायरेक्शन में आपने यूनिट लोड लगाया है उसी डायरेक्शन में डिफ्लेक्शन है. अगर ये नेगेटिव आती है तो उस मतलब उसका ऑपोजिट है. So the calculation of deflection of truss joint can be given in a tabular manner. So आप इसको निकालने के लिए देखिए आपके यहाँ पे कितने सारे मेंबर्स थे? 13 मेंबर्स थे. इसको ऐसे अगर आप ऐसे सॉल्व करने जाएंगे तो थोड़ा टिपिकल हो जाएगा, तो इसलिए हमने क्या बनाया? टेबल बनाया. टेबल फॉर्म में बनाएंगे तो इजीली कैलकुलेट कर सकते हैं डिफ्लेक्शन एट दैट जॉइंट. तो फर्स्ट ऑफ ऑल इन द टेबल यू हैव टू मेक द मेंबर सेक्शन. मेंबर कॉलम बनाएंगे, पी लोड ऑफ फोर्सेस, के लोड ऑफ फोर्स, के सिस्टम ऑफ फोर्सेस, फिर लेंथ एंड पी के एल. तो इसके बाद आपको समीशन ऑफ पी के एल करेंगे डिवाइडेड बाय ए. सो ये क्या आ जाएगा? डिफ्लेक्शन आपका उस जॉइंट पे। अब सेकंड केस कहता है ड्यू टू वेरिएशन ऑफ टेम्परेचर। अगर आपका टेम्परेचर वेरी होता है तो ट्रस पे क्या इफेक्ट पड़ेगा? इफ द टेम्परेचर चेंजेस अकर देन द डिफ्लेक्शन ऑफ ईच मेंबर विल बी, हर मेंबर पे जो डिफ्लेक्शन आएगा दैट विल बी एल अल्फा टी। अल्फा क्या आ गया यहाँ पे? कोफिशिएंट ऑफ थर्मल एक्सपेंशन. So where T is the change in the temperature, T is taken positive if there is rise in the temperature and taken negative if there is fall in the temperature. So अगर temperature increase कर रहा है तो positive लेना है, अगर decrease कर रहा है तो negative लेना है. Hence the deflection at joint C due to change in temperature in various member is given by this. Okay. So आप इसका summation करेंगे, summation of फ्रॉम आई इक्वल टू 1 टू n तक जाना है और दैट विल बी इक्वल टू एल अल्फा टी तक जाए, सबका ये रिफ्लेक्शन होगा. अगर आपको दोनों केसेस के लिए सॉल्व करना है तो दोनों का क्या हो जाएगा? समीशन ऐड हो जाएंगे दोनों फोर्सेस, सो वो टोटल रिफ्लेक्शन आ जाएगा. सो आफ्टर दिस वी विल बी सॉल्विंग द न्यूमेरिकल. So now we have to discuss this numerical, the vertical deflection of node C for the given truss shown in this figure. So this is the truss here. Here P load is given. So you have to calculate the deflection of node C. So what you will do, you will apply a unit load at C in the downward direction to calculate the vertical deflection. Okay, so first of all you have to calculate the reactions. In this numerical, as we are dealing with the C joint, so here we don't require to calculate the reactions value. You can calculate the values of the member forces from this. So I will take a joint C, and in joint C I'm drawing here this joint. Okay, so this is a C joint and this is 30 degree and this is 30 degree. Okay, and this force is you can say P CA and this force is P CB. Okay, now you have made these member forces and here one force is there, that is P. So for calculating the member forces, I am applying a equilibrium equation that says summation Fx equal to 0. With this, first of all, you have to break these forces into components. Here PCA is here, so this force will be PCA cos 30 degree, and there is, due to this PCB there will be one force, that is PCB cos 30 degree in the same direction, and due to this here one force will be PCA sine 30 degree. Okay, and in this direction of P one force will be there, that is PCB sine 30 degree. Now as you have broken these forces into the components here, now see the forces direction in x direction. So let us take, if you are taking this direction positive, so let us take this direction negative. So from this you will get PCA cos 30 degree negative minus PCB cos 30 degree equal to 0. From here you will get PCA equal to minus PCB. Okay. So from here I have calculated the equation PCA equal to minus of PCB. Now you have to apply the second equilibrium equation that says summation Fy equal to 0. From here now I will see the forces direction in y direction. Let us see upward forces are positive and downward forces are negative. So from here I will make a equation PCA sine 30 degree minus PCB sine 30 degree plus and sorry minus P equal to 0. From this we will get, as we know the equation, PCA is equal to minus PCB. So I am putting here minus PCB sine 30 degree minus PCB sine 30 degree minus P equal to 0. Now solve this equation, and this will be minus minus plus minus 2 PCB sine 30 degree equal to P. Okay, sine 30 is 1 by 2. 2 cancel out P. So from here PCB equal to minus of P. So from here we will get PCA equals to minus minus plus. PCA is equal to P. Now we have calculated the member forces due to the external loading. Now at the same joint, now again I am making that same joint here, that is PCA and this is PCB, and this is 30 degrees and this is 30 degree, and in that direction of where you have to calculate the vertical deflection, I am applying a unit load. Now due to this unit load, calculate the moment member forces by applying same equilibrium equations, summation F equal to 0. From here you will get PCA equal to minus of PCB. Same here you can similarly break the components here. The components will be same here. Okay, but the other equation will become that after you start solving here, this will be equation that minus PCB sine theta minus PCB sine theta minus P. But in here in place of P you will get 1 value, because P value is 1 because we have taken a unit load there. And from here you will get the value of PCB, or you can put the value of, instead of P you can say K system of forces. So KCB will be equal to minus 1 and KCA will be equal to 1. Okay, similarly after you have calculated these forces, member forces, then you can either make that table, and this is not that big truss, so you can easily solve by putting in the formula that deflection at C is equal to summation of PKL upon A. First of all, 1 P value is, K value is 1 here. First of all you have to take the member AC. For member AC, CA. For CA value, the member force is P. So I am putting a member force is P. Length is L. And K value, PCA value is 1. Okay. Divided by A plus. Now see the value of PCB, that is minus P. Length is L and K value is CV is minus 1. So minus minus get positive, and this becomes 2PL upon A. So this is the deflection, vertical deflection at C point. So the second numerical says the right triangular truss is made of members having equal cross-sectional area of 1500 mm square, and Young's modulus is 2 into 10 power 5 megapascal. So the horizontal deflection of the joint Q is, so now you have to calculate the horizontal deflection of the joint Q. So this is P, this is R, this is Q. So now when you have to calculate the horizontal deflection of the joint, so you will apply a horizontal force in that direction. Okay, now first of all you have to calculate the unknown reactions. For that, so let us see the support condition here. This is a roller support. So roller support will be having one unknown, that is, let us say VP equal to, that you have to calculate one, that is hinge joint. This will be having one vertical and one horizontal, that is HR. So first of all, apply the equilibrium equations, that says summation fx equal to 0. From here you will get HR equal to 135 kilonewtons. Now you have one unknown value. From second equilibrium equation, summation Fy equal to 0, you will get Vp plus Vr equals to 0. There is no vertical here. So let us put the third equation, that says summation moment about, let us take P point equal to 0. So when you are moving towards the P point, see the other forces, that says VR into 4.5, and this is anti-clockwise direction. If you have taken anti-clockwise positive, then you have to take clockwise negative. Clockwise is 135 into 6 equal to 0. So from here you will get the vertical reaction VR equal to 180 kilonewton. Okay, and VR is 180 kilonewton, so VP will be equal to minus 180 kilonewton. Okay, now you have calculated the values of the unknown reaction. Now you have to calculate the member forces due to the external loading. For calculating the member forces, let us take joint R first. So see the joint R, how many forces are going in this R. So VR is going upward and HR is going towards this side. So this is R joint. One force, that is HR, is coming, that is 135 kilonewtons. VR is going upward, that is 180 kilonewtons. And one force will be going this side, that is force P R Q. And one force in this direction, that is P R P. So for calculating these member forces, put the equation summation Fx equal to 0, and from here you will get PRP plus 135 equal to 0. So from here you will get PRP equal to minus 135 kilonewtons. That means the direction of the assumed member force is in opposite direction. Now apply the second equilibrium equation, summation Fy equal to 0. From here you will get PRQ equal to minus 180 kilonewtons. So as you have calculated these member forces, let us take the other joint, that is joint P. So joint P, see the joint P, this. So let us make this joint, this is like this. One force is going downward, that is 180 kilonewton, because the direction of VP is minus 180 and we have assumed upwards, so minus sign indicates that it is going downwards. So this force is in this direction, that is PR, okay, and this will be PQ. So this angle is theta. Now for this you have to put summation Fx equal to 0, and second equation is summation Fy equal to 0. Now start seeing this, as P as you are in this joint. So this is horizontal, this is vertical, and this is inclined. So you have to break this into component. That is, this angle, this force will be P Q sine theta, and this will be P Q cos theta. And theta you can calculate. This is 4.5 and this is 6 meters. So theta you can calculate tan theta equal to perpendicular upon base. And theta will be tan inverse of 6 by 4.5. So you will get the value of theta. P summation Fy. We are taking the second equation. From second equation we will get P Q sine theta equal to 180 degree. Okay. From here you will get PQ is equal to 180 upon sine theta, and sine theta is, after putting this value we will get 225 kilonewtons. So you have all the member forces now. Okay. Now after calculating all the member forces, here I have done that sine theta will be equal to perpendicular, that is 6 upon hypotenuse 7.5. Okay, you can calculate the hypotenuse, so you can get the value of this. So after calculating the member forces with the external loading, now you have to calculate the member forces due to point load. So in the direction of this Q joint, you have to calculate the horizontal reaction. Now you can make this truss again, okay, like this. And in this direction you have one unit load here. Now you can calculate the member forces due to this load and calculate the value of member forces due to point load. From here you will get the value of PRP, or and you can say that as you can take the force system as K force of system. Okay, K force system. So that will be KPRP, KRQ, and KPQ. So after calculating the member forces, you have to apply all the values in that table, in which you will first of all write the members, then you will write the P load and K load and length of the member, and then easily you can calculate pkl value and divide that by the ae value, and you will get the deflection at that point. I hope you have understood this concept behind the calculation of deflection in the trusses. So this was the last topic in this unit. So we will be discussing the other topics of the other units in the lectures to come. Okay, so until then, thank you very much.